Hey, just a quick video. I'm looking to change my or get some extra batteries for my lawnmower. I've got a Ego electric lawnmower. I've had it for about 8 years now. So the original battery that came with it is not lasting very long. I did get a replacement battery a couple of years ago, but I really need two to do the front lawn and the back lawn comfortably. So what I was looking at was on Amazon. They sell third-party Ego batteries or Ego style batteries. As you can see, if I wanted a 7.5 amp hour Ego OEM battery, it's over $400 now, which is a lot. I don't really want to spend that much. And then I saw there's an awful lot of third-party batteries now from different people. It looks like it might be just 2 or 3 different manufacturers, different styles of batteries, but there's a lot of sellers for these. So I wanted to get these in and see how much charge they actually hold, whether they seem to be well made, and whether they'll work as a second battery. So that's what this video is about. First I have a look at my existing batteries, see what sort of charge they still hold, and then I'll have a look at 1 or 2 third-party batteries to see what their characteristics are. Okay, here's the fleet of batteries I have now. So first couple, or first 3 I got originally when I got my Ego tools about 8 years ago. So first 2 2.5 amp hour batteries, and then the one in the middle is a 7.5 amp hour battery, again 8 years old. Then about 3 years ago I bought another 7.5 amp hour Ego battery, and this battery is the one that I end up choosing, a third party one, after doing my tests. So the tests I performed on the battery, so first I just weighed each battery, and then I was using a battery load tester to check how much charge was in the battery. I also connected up a voltmeter and tracked the voltage as the load test ran. I just used a couple of paper clips to connect up to the battery. It seemed to work well. And this is the load tester I used. This wasn't the exact one, I got a cheaper one, but I ran it at a load of 130 watts. Okay, let's just have a quick look at the architecture of the Ego battery pack. So each battery pack provides up to 56 volts, and they're using the 18650 lithium-ion batteries inside. Each one of these batteries provide about 2.5 amp hours of power, and they weigh about 45 grams. So if you buy a 2.5 amp hour Ego battery, it's got 14 of these 18650 batteries in series to provide the 56 volts, because each one of these batteries provides about 4 volts, and so it'll provide 2.5 amp hours at 56 volts in this combination. And that many batteries probably weigh about 630 grams. There's a bit of variance for different lithium-ion batteries. If you buy a 5 amp hour Ego battery, then it basically provides another 14 of these 18650 batteries in series. But those 2 series of batteries are then put in parallel, so it provides a total of 2.5 plus 2.5 amp hours, or 5 amp hours. So, and then the weight would be closer to 13 or 1.3 kilograms for 2 sets of those batteries. And so for a 7.5 amp hour combination, we'd have 3 of these 14 battery series in parallel to provide a total of 7.5 amp hours at 56 volts, and then our weight would be closer to 19 or 1.9 kilograms in just batteries. And finally, for a 10 amp hour battery, there'd be 4 of these 14 battery packs in series or in parallel. So what this is useful for is just to give you an idea of how much a certain battery power combination should weigh, or how much it should not weigh. So sometimes when you look online at some of these larger 10 amp hour battery packs, they don't seem to have the weight that would indicate that they've got that many batteries in them. So I'd be suspicious of those ones. So bear in mind that there's also packaging of the batteries, the power management weight, and the actual case for the whole thing added to the weight as well. So it's not going to be exactly what the weight of the batteries are. It's probably going to be maybe an extra pound or 2 pounds of weight in the batteries, depending on the size of the whole case and contents. But it gives you an idea of what the minimum should be based on the number of batteries that you'd expect for a certain amp hour combination. So this shows the load test being fired up. So I've set it to 130 watts continuous power load. Press the button to turn it on. In this case it ran for about 2 hours to fully discharge the battery. I have it run down to 42 volts. At the same time as I was running this, I was also graphing the voltage discharge on the battery, so you can see this is how it discharges, and it's kind of typical for these sort of batteries where once it gets down to about 47 volts it drops off pretty fast. And then the load tester shows the final result at the end. So these are the results as a chart. So the first 3 batteries are the 8-year-old ones I got when I originally got the equipment. So they're down to about 55% of their rated power. So, the next battery was one I bought about 3 years ago, so it's already gone down to about 82% of its rated power, but it's probably my best battery there. This battery here I got online. It's an OEM one. It's meant to be 10 amp hours, but only came in at 6.5 amp hours. I might have used it, but I didn't like the power indicator on it as well, so I sent that one back. And I ended up getting this one 7.5 amp hour rating, and then it only had 5.5 amp hours of power in it, but that's fine for my needs. So this is the battery I finally ended up using. Like I showed, it's about 73% of the rated amp hours, but that was fine for mowing the lawn. I actually tried it out in the lawnmower a couple of times. Seems to run between about 25 and 30 minutes, depending on how thick it has to cut through, which is fine. It gets me through the front lawn, and then I've got the other battery that I can get through the back lawn on, so it solves my problems anyway. And it being about a quarter of the price of a normal Ego OEM battery, I consider it a pretty good buy.